Good morning. I am Reggie, Associate Professor, Department of ECE. Today we are going to see about Introduction to Transmission Line. Introduction to Transmission Line. On completion of the course, students can able to understand what is meant by transmission line, what are the application of transmission line, define characteristic impedance. So a transmission line is a device designed to guide electrical energy from one point to another. It is used to transfer the output RF energy of a transmitter to an antenna. This energy will not travel through normal electrical wire without greater losses. Although the antenna can be connected directly to the transmitter, the antenna is usually located some distance from the transmitter. So there are many types of transmission wire: coaxial cable, twisted pair cable, parallel wire, and IC interconnect. Introduction to transmission line. This propagation is one of two reasons. One is power transfer, another one is information transfer. Power transfer. Power transfer is nothing but the process of transferring the power from one point to another. Just you can see example. Information transfer. Information transfer can be done by means of the satellite or by electrical wire from one end to another one end. On board transmitter is located inside the radio room and associated antenna mounted on the mast. A transmission line is to connect the transmitter and antenna. The transmission line has a single purpose for both transmission line. Transmission line theory. The general characteristics of two-wire transmission line mainly depend on the construction of the line. The two-wire act as long capacitor. The change of the capacitive reactance is noticeable as the frequency applied it is changed. Since the long conductor have the magnetic field, when the electric energy is being passed from the property of inductance. Distributed constant. Distributed constants are spread through the entire length of transmission. The amount of inductance, capacitance and resistance depend upon the length of the wire. The size of the conducting wire, the space between the wire, between the media. Resistance is defined as loop resistance per unit length of the wire. Its unit is ohm per kilometer. Inductance is nothing but loop inductance per unit length of the wire. Capacitance is defined as loop capacitance per unit length of the wire. Unit is farad per meter. Conductance G is nothing but loop inductance per unit. Application of transmission line. It is used to transmit signal EM wave from one point to another. It is used for impedance matching. It is used for circuit element like inductor, capacitor. They can be used as sub properly adjusting the length. Wavelength. Wavelength of a line is defined as the distance the wave travel along the line while the phase change is from 2 pi radian. Characteristic impedance is the impedance measured at sending end of the line. Z0 is equal to Z by Y. Z is equal to R plus J omega L series impedance, and Y is equal to G plus J omega shunt admittance. Secondary constants are characteristic impedance and propagation constant. R, L, C are distributed constant and they are as primary constant. Infinite line. A finite line is a finite length of the line. Infinite line when the length is infinite. So the input impedance of the finite line is equal to the characteristic impedance. Infinite line is the line, length of the transmission line is infinite. A finite line which is terminated by the characteristic impedance is called infinite line. So infinite line input impedance is equal to characteristic impedance. So finally we can see the topic quiz question or what you can analyze from this topic. So just we discussed about the transmission line, types of transmission line, application of transmission line, and just you can see about what is the important parameters. The following parameter does not